Hello everyone, my name is Andrew. I work at Compare the Market and I've worked there for about 7 months now. Although I look like I'm 12, I've actually got more than 15 years of experience of working in IT, so I guess I kind of know roughly what I'm talking about. So I'm here today to talk to you about kind of development. So we're going to talk about development and programming without getting too technical. The idea really is to let you be able to talk to programmers or developers and understand a bit more what's going on when they're talking, or if you're working in a QA role, to understand where the problems might be when people are developing things and things like that. So we're going to learn about the concepts of programming. I purposely didn't call it concepts of programming because there'd be even less people here if I called it that. We're not going to talk about a particular language, we're just going to talk about concepts in general. And as I said, I'm not going to try and teach you how to be a programmer, I'm just trying to teach you the ideas and the thinking behind it. And so you can talk to developers and communicate better with them. It will contain lies. This is not to deceive you, it's not to trick you in any way, it's just for simplicity. So if something's not quite 100% correct, don't shoot me. Okay, so when people talk about or think about programming, often they think it's a difficult concept or something scary or something they can't understand. But you don't need to be scared, it's not magic, it's easy. It's just giving a list of instructions for the computer, and as long as you can speak that language or understand that language, that's all it is. It's just the same as following a recipe. It's do this, do this, do this. If you want to do this, do this. Simple. Anyone can do that. So these are the kind of areas we're going to cover today. We're going to cover variables. We'll come on to what these all are in turn. Variables, functions, control structures, and loops. But first, we're going to do a quick exercise. So on this board over here, what we're going to do is we're going to try and draw, as a 6 people or whoever in this room, we're going to try and draw a smiley face. So can someone tell me the first step about drawing a smiley face? Anybody shout? Draw a circle.
Yeah. It's a big circle.
Big? The point I'm trying to make here is that when you're talking to a computer, you have to be very specific about what you're saying. You can't just say, draw a circle. A computer's got no concept of a bigger circle or what that is. You need to be specific and explicit with what you're telling the computer to do. So you need to make sure that everything you're doing is very specific and very detailed on what you want to do. So in that case, what we want to do is draw a circle the size of the paper, and then draw 2 circles that are 5 centimeters in diameter at the top left quarter or something like that. We have to be very specific and very definite about what we want to do. We can't just be wishy-washy, draw a circle, because that doesn't help. Okay, so we're going to start talking about variables. Now, you may have noticed there's some buckets on the floor. Now, variables are just like buckets, and we'll come on to this in a second. They're a place to store something which you need to get later on. So if you want to put something in a bucket, you can put it there, you can go back later, you know it's still going to be in there, you can pull it out, and it's still there. So you could add things to a bucket, you could take things out, you could change the contents of the bucket, you could do something with that bucket. Say it had, I don't know, say you were mixing cement or something. You've got the cement in there, you want to put your water in, they're all actions you're doing to it, and you're changing the contents of that bucket or that variable. We'll come on to how that works in programming as well. So some examples that you might want in real life of programming is when you log into a website and it's got your username. So it shows, welcome James or whoever. That will be stored in a variable so that every time we need to get it, we can go and look at that variable, get the contents, and we know what that is. It's a piece of information that we've populated. We want to get it back later on. We know where it is to go and get it. Okay, so this is a code example. Don't freak out, it's fine. So this is what I mean about variables of buckets. So I'll just run through the code and I'll show you an actual example with a bucket. So if you look up here, this code basically says create a variable called reminder and put this sentence in it. So create a variable called reminder and put the sentence variables are buckets in it, and then output, this console log means output, what's in that bucket. Okay, so that's simple. What we're doing is we're getting a bucket called reminder, as you see there, and then we're taking our sentence called variables of buckets and putting it in there. So that when we want to get it out to see what's in there, we look in there, oh look, we know what's in there, easy. And what we can do as well, as I said earlier, is we can change the contents of that bucket at any time. So if I want to change my reminder to something different and put something in it, I can overwrite that. So when I put my updated value in, when I go and look what's in there again, that's now my value. So I've changed the contents of the bucket, and that's exactly what we're doing here. We're saying, with this reminder bucket we've created earlier, put this sentence in and then get me the value. So it's exactly the same as putting things in a bucket and taking them out. So you can think of it like that. There's different types of variables as well. And just to show that, I've got a different type of bucket here, which is called favourite number. So just like in our previous example where I've done var reminder, this would be var favourite number. And in here I've actually got a number stored. So the point I'm trying to make is there's different types of variables we can have. So just to run through a few of them, we've got a string or a sentence, which is a bit like this one. We've got an integer, which is a whole number. So whatever that might be, 326, 5,422,156. And then, similar to that, a different type of number is a float or a double, which contains a decimal point. So not a whole number, so like my favourite number. That is an example of a float. We've got an array or a list, which is literally as it sounds, a list of objects or list of items inside of that. And we've got what's called a Boolean or a bool value, which just says true or false. So is something true or is it false? And we'll come on to see some of these later on as we go through. I see a couple of you scribbling, so I'll just give you a second. So what can we do with variables? I mentioned earlier the example about mixing cement or things like that. What can we do with our variables? So, excuse me, in this example here, we're doing the same thing we did earlier. So we're creating a new reminder variable and putting don't eat yellow snow inside of it. And then what we're doing after that is we're writing out to the screen, don't forget, and then the contents of the reminder variable. So in that case, that will write out, don't forget, don't eat yellow snow. That's quite simple. But you can do different things depending on what type the variable is. So when we saw a minute ago, we saw the different types. We saw a string, an integer, a float. You can do different things on that. For example, if you've got a string, if you've got a string or a sentence, you can't increase the value of that by 1. It just doesn't make sense. Whereas if you've got a number, you can do mathematical operations with that. And that's what we can see at the bottom here. So imagine I've got 4 apples inside a bucket, and then I eat one. I've only got 3. So that's exactly what's happening here. So I've got 4 apples inside my apple count variable. I take 1 off that because I've eaten it, and then I output that, which is going to be 3. So that seems, again, quite straightforward. So that was a very quick run through of what variables are and what types are. So we're going to do a quick quiz to see how much you've been listening. So what type is a number with decimal places? Don't look at your notes. What? With decimal places? Double or a float, that's fine, yeah. So you see that there? True or false? And a list of items is called an array. It's true. It's true. Sorry. It's true. And what will this code output? So if we think about what we did before, we're creating a variable here, and then when we're calling it back, we're going to get the contents of that variable.
Hello, James. Nice to meet you.
Exactly. You're a programmer now. It's easy. There you go. Okay, so just a quick recap. Variables are like buckets. You can fill them up, take things out, change what's in them, do things to what's in them, and they're still there when you want to get the value later on. Now, if we're talking about my recipe analogy from earlier, the variables are a bit like the ingredients. So when you see at the top of a recipe, you see get 500 grams of flour, get, I don't know, 2 pounds of caster sugar or whatever. That's all, that's like a variable. So you're taking that and using it later on in the recipe. So at the start, you'll collect all those things together that you need, which is what a variable is. Collect all the data you need at the top, and then you will then go on to do things with those variables. So the next thing we need to talk about is functions. And functions are the actions. And they're the actions that do things on variables. So they're like, kind of like verbs. They're the actions of doing things that we're actually as part of our program. So as it says there, they're pieces of code that perform some logic and then tell you a value at the end of it. So we're going to go on to some examples as well. So say it's Thursday night and you've got to put the bins out ready for collection for the next morning. So the steps that we go through to do that, if we actually break it down and think about it, we've got to find the bins first. We've got to know where they are. We've got to find the gate from our back garden to our drive, for example. we've got to open the gate, we've then got to find the curb, the destination where we've got to take the bins, and then we've got to move the bins to the curb. Now each of those could be functions. So to make putting the bins out done, to make that complete and to do that, we would follow those steps. That's what we do if we thought about it logically. Now, we could write all of that code in one big function to say, put the bins out, and we could do all those steps. But then what about if we want to find the gate for another reason? If we want to find the gate to, I don't know, go into our back garden or go to the drive or get in our car or whatever, we would then have to duplicate that code even though we're doing exactly the same thing. So what we'd really do in this case is we'd split down each of these sections into separate functions, and then we would just reference them or call them from our main putting the bins out. So then if we needed to do any of these other bits in between, or for any other purpose, we can call them again and we can reuse them. And later on we'll come on and see why that's a really good idea from a code point of view, or even from a QA or BA point of view, why you'd want to do that. And yeah, it says there, the functions are like the steps in the recipe. So we're back to a code example again. So at the top here, what I've done is I've created a function called add 4 and 8. So anybody want to guess that what it's going to do? It's going to add 4 and 8. So this thing here, return, just means tell me the value of. So when this function runs, tell me this value. So this is literally going to add 4 and 8 together and tell us the value, because it's got return before it. So whenever we say to the code, like here we're actually calling that, we're actually telling us to do some work. Here we call it, we say add 4 and 8, and that will return us the value of 12, because that's what 4 and 8 is. And that will put that inside this variable here. So where earlier we saw like the variable equals a particular number, that's exactly what we're doing here, but we're getting the function to calculate the number that we're putting in there instead of just typing the number in. So instead of typing return value equals 12, the function is telling us that the value we want to use is 12 for that. So there exactly you can see what it does. It adds 4 and 8, and then it outputs 12. And we can call that function wherever we want to use it. And this is kind of starting to talk about where we would reuse code and how we'd split functions down. So you see here we've got two variables here, two different variables, one which is called return value and one which is called 4 plus 8. And they both call this add 4 and 8 function. So they're both going to equal 12, we can see here, which is fine. And that is fine. But then what happens if we want to add 5 and 9? Or we want to add 2 and 7? Or we want to add 6 and 422,652? We don't want to have to write a function for each combination of numbers. That's just no point in doing that. So what we can do here is we can have something called arguments. And we can pass data into the function, and it will give us values back. So if we try it with somebody in the room, you, madam, if you'd like to volunteer, thank you. You don't have to stand up, it's all right.
It's all right.
So what I'm going to do is you are now the add two numbers function. So whenever I give you two numbers, you're going to tell me the answer of their addition. So if I say 1 and 2,
3.
exactly. If I say 22 and 6,
28.
exactly. That's all this function is doing. There's nothing clever. That's the point I'm trying to get across. There's nothing clever about programming. There's nothing difficult or intricate. It's all very logical. It's exactly, you just got to kind of frame yourself, frame your mind to be in the right, I guess you've got to be in the right frame of mind and understand exactly how it works. But there's nothing complicated or nothing difficult about it really. It's just following steps. So that's exactly what this function does here. So you see inside these brackets here, you're passing in, we would pass in here 15 and 45. So we're calling this function, add two numbers here, and in this case we're passing in 15 and 45, and that will give us 60. And in this case we're passing in 11 and 677, and we get 688 as the result. So that's when we start to talk more about reusability. We saw in the previous example, if I go back to that the add 4 and 8 is not really a useful example because we're using these hard-coded values 4 and 8. But when we get to this kind of concept, where we're passing in arguments or parameters they're called, we can actually start to build up some useful code rather than just getting the value of adding two things together. Okay, so this is a real-life example of why you should split code down. Because I was working on an e-commerce project when the VAT rate changed. So it changed from 17.5% to 20%. And some kind developer before me had littered 17.5% in calculations all across the code. So I didn't just have to go and fix it in one place, I had to fix it across the whole code base in 5 or 6 different places, just because the VAT rate had changed. So there might be a bit that When you show your order summary, it calculates it, and when you show your shopping cart, it calculates it, and they were all separate bits of functionality. They weren't reusing the functionality like we talked about when moving the bins to the curb. They weren't reusing it. They were writing the code out every single time to calculate that. So that when it actually changed, it was a right pain to go and find all those examples where it was used so we could fix the problem or change it to 20%. So a better way for that to be written would be to actually call this, to create a function calculate VAT, for example. And then we can pass in an amount to that, and it will tell us the VAT rate for that amount that we've passed in. So in this case, we've got this function calculate VAT, which takes an amount as its first parameter. And then basically it just works out 20% of that value that we've passed in. So we're saying return, tell me the value of the amount I've passed in times 0.2, so 20% of that. So then later on, if we come to call that function, which is calculate VAT, and the sale amount is 10, then it'll give us 2. And if we call calculate VAT on £41.76, it'll give us 8.35. I'm sure you all worked that out in your head before I went on to it. Yeah, so we only change it in one place, and it means that if there's a bug in that code, I've only got to fix a bug in one place as well. I haven't got to fix it in 17 places. It's all in this one place. It makes it easier to test, quicker to develop, easier to find a problem, and easier to fix if there is a further problem after that. Okay, so quickly we're going on to this. So what is the name of a piece of information that you pass to a function? So what I'm talking about is these things here. What are these called? Come on. Parameters. Yeah, parameters or arguments are both fine. So is this true or false? A function can take no arguments. So if we think about our add 4 and 8 earlier, we didn't actually pass anything into that, did we? It was just add 4 and 8. We didn't pass any, if I go back to that quickly. We didn't pass anything into it. We just said, tell me the value of 4 and 8 of the values we defined in here. So we're not actually giving the function any information to work on. It already knows what to do. And why do we break code down into functions? Oh, why do we break code down into functions? Yep, it's that. To increase reusability and maintainability. That's why we do that. Okay, so functions are used for isolated pieces of code that you're going to reuse. If there's a bug or problem or you need to make a change, you can make it in one place instead of 15. And that's it, really. Okay, quickly we're going to control flow and conditionals. Now this, oh, hang on a minute. Functions are like the steps in the recipe. So if we go back to that example of where we passed in 2 things, we might have a mix function, which takes flour and eggs. We also might have a mix function, which takes cream and egg whites. So it was the same mix function that we were using to do the same action, but we're passing different things into it. So if you think of a recipe, that's something you could do with multiple different things. So we'd have 2 parameters that we passed in, which are the 2 things we want to mix together. Okay, so we're talking about control flow now. So this is where we actually add logic. At the moment, we've got code variables that contain the things we want to work with. We've got functions, which are the actions. And then we've got control flow. So this actually defines the behavior and, or what to do in certain scenarios. So there's a couple of scenarios at the bottom there. If today is my birthday, I should eat some cake. It seems fine. Whilst I'm still hungry, I should eat some food. I think I must have been hungry when I wrote this because it's all about food. Or the third example is for every letter that comes in the post, you're going to open them and read them. This is all to do with conditionals and control flow. And it sounds like a complicated term, but again, it's not. It's really straightforward once you actually know what they are. So if we were talking, let's go on to an example. So an if statement, this is the one we talked about is it my birthday and should I eat cake? So if my birthday, we've got a variable here called my birthday. So if my birthday is the 23rd of February, but today's date is the 24th of February, what we do here is we check if those values are the same. So this double equals means, are these 2 values the same? So if they are, then I'm going to eat some cake. If not, I'm going to be very, very upset. But as you can see, they're not the same, so it'll actually go onto this piece of code. So this eat cake code will never run because these 2 values are not the same. But if it was the previous day, so if it was actually the 23rd of February and those 2 values matched, then we would go on to eat the cake. Okay? So if we go back to our recipe idea again, that if you were making scones or scones, depending on how you say it, if you're making savoury scones, you'll put different ingredients to it if you're making sweet scones. So that's kind of 2 different case scenarios there where you'd do different things based on what you actually want to do. So a switch statement is a little bit more complicated, but it's really just an if statement with lots of conditions. So instead of being if this or this, it's if it's this or this. So the example here does something different depending on what day of the week it is. So if it's Monday, you'll see a message saying 5 days till the weekend. If it's a Tuesday, you'll see 4 until the weekend. If it's Wednesday, you'll see it's the middle of the week. So again, if we go back to our cooking or recipe example, if we work in Domino's or any other pizza shop and you get an order on the phone, you have to put a different topping on that pizza depending on what the customer ordered. So in this case, it might be case margarita. Okay, I'll just add cheese. Case barbecue chicken, I'll put barbecue sauce on a chicken. Or so you're doing a different case depending on each what criteria we actually want to achieve. Okay, while statement. This is the most complicated code you will see in this presentation, but it does require audience participation. And I've just been told I've got 5 minutes left, so we're going to have to be quick with this. So I need 3 volunteers. All come to the front when you're ready. Thank you. One more, come on. Anya, come on. Yeah, it's eye contact's what it is, it's the key. Okay, so we're going to get rid of this. So, Robin, you are going to be the variable stomach percentage. If you can quickly see the code behind as well, you'll see that stomach percentage is currently set to 70. And if Robin just lifts the 70 value up, you'll be able to see that that's the current content of that variable. So if you remember when we talked about buckets earlier, that is the current content of that variable. Okay, that's fine. Anya, you can be hungry, the function hungry here. So when you are called, when I point at you, what I want you to do is I want you to literally pick up this value that's in there and see if it's less than 100. So if you see on the screen here, we're saying if the stomach percentage value, so if that's Robin's got in that variable, is less than 100, then after you've done that, I want you to say true. Okay. If it's not, so if it's not less than 100, I want you to say false. Okay? I'm sorry, I don't know your name.
Linda.
Linda, okay. So Linda, what I want to do, you're going to be the eat food function. So what you should do at that point, whenever I point at you, is you go to this variable and you, with this pen here, you cross off the current value and add 10 to it.
Cool.
Okay? So if you just like to step to the side so everyone can see the board as well. So what we're doing here, as I said, we've defined our variable, stomach percentage, which is Robin, and he's got the value of 70 in it. Anya is this hungry function here. So she's going to check the value of that, check if it's less than 100, and she's going to say true. So she is still hungry. And if it's not less than 100, she's not hungry anymore, so she's going to say false. And Linda, what you're going to do is you are going to pretend to eat food. So you're adding 10% of fullness to Robin's value. Okay. So we've got this while loop at the moment down here. So we're actually going to get on and run some code now. So what we're trying to do is, whilst I'm still hungry, I should eat some food. Okay, so we're going to start now. So we're going to say, Anya, are we still hungry? So she's going to go and look in that variable, and it's less than 100, so she said true. So now Linda, yeah, that's exactly right. So Linda's going to do that. She's going to eat food because hungry was true here. Okay, so we've been through once. So we've been through, we've checked if we're hungry, and we've eaten some food. But we're going round again now, so because we still want to check whilst we're still hungry. So Anya's going to check that value. And it's 80, which is less than 100, so she still says true, I'm still hungry. So then Linda's going to check, and she's going to add 10%, she's going to eat something, and add 10% to that. So we've done that again, we've got through the second time, but it's now 90. So if we run it one more time, are we still hungry, Anya?
True.
So Linda's going to add some food. And now we're going to check one more time, are we still hungry? So that's 100% now. I'm 100% full, so that's the end of the program. It's just a little demonstration of how it's going to work. So that's it. Thank you very much. That's all you need to do. You can keep your bucket for now. Okay, so this is just one more quick example of a for loop. So what we would do here, as I mentioned earlier, is we've got a list of letters, and we're going to go through each of those and read them in turn. So when we get home at night, you've got a list of letters lying on the doormat. We'll go through each one in turn and read each of those letters. That's what a for loop is. It means do one action for all of the things in this list or this array that we talked about earlier, this list. Okay, so very quickly, we're going to run through this. So when you want to check if something's true or false, which conditional should you use? We're checking 2 cases here. Not lots, just, sorry? Yeah, so it is a Boolean.
Every
No, that's right, it is a Boolean, but you actually use the if statement. So yeah, you're right that the true or false thing is Boolean, but you use the if statement. Oh yeah. So is this true or false? A switch is very similar to an if statement with lots of different conditions. If you think about our pizza example, yeah, that's right, Anya, it's true. And if you want to loop through a list of items, when we just saw on the previous slide with the letters, what statement should we use? Oh, I've done it again. So we should use a for statement to go. So for each of these items, we're going to go through and process them. So we mentioned earlier, yeah, this is the conditionals. We've talked about how that relates to recipes. If you want to make savoury scones or sweet scones, that's the condition, or if you want to do toppings on a pizza. So we're coming to the wrap-up now. We've talked about variables. They're temporary storage of whatever value we might need later. You can change them, you can do things to them, you can whatever. We've talked about functions. There are actions, there are things we do with the rest of in our code. And the control flow and conditionals are what do we do if we want different types of functionality. Now I have got a bit of a confession. At the start I said there'd be some lies. And one of the lies I told you was that none of the examples would be tied to a particular language. That was a blatant lie. All of those examples were JavaScript. So if you understood those examples we went through today, you can understand how to program in JavaScript, or at least the basics anyway. So you've learned not just about how the code works, but also you've learned the basics of JavaScript as well. And that's it. Any questions?
Can you email that to me, please?
Yes. Yes. If you want to ask me other questions outside of this, you can email me or get me on Twitter. Okay, that's it.